So once I have already shown you how to create the Spark session, but let us see that once again. Okay. So here we are entering. Now we understood what is Spark, what is Pyspark, what is Databricks, why we need Databricks. All basics done. Now we will enter to the coding. Okay. So we know, everybody knows that Pyspark is the Python API for Apache Spark, and Apache Spark is the powerful open source distributed computing framework which is used for processing large scale data. Okay. So highlights, when it comes to highlights, so Python plus Spark together we call it as Pyspark. Okay. Python code which helps you to access the Spark. Okay. And it is used for distributed computing. It can handle the big data, that is data which is in GBs and TBs. Okay. And it is also used in data engineering, machine learning. Okay. So this was about PySpark. What are the capabilities of Pyspark? It is used in big data processing, distributed computing, data engineering, ML at scale and streaming. So these are the application what Pyspark can do. Okay. So it can, first and foremost usage of Pyspark is it helps you to handle data sets. Okay. The data sets which are in GBs and TBs. Okay, GBs and TBs, which traditional tools like pandas cannot manage. Your pandas cannot manage such big data which is in GBs and TBs. So that's why we go for PySpark. Then it allows you to have the distributed computing also. Distributed computing means what? We are breaking the big task into small pieces of task and we run them into across many machines at the same time parallelly. Okay, that is distributed computing. Then when it comes to data engineering, here it helps us to build the robust ETL pipelines. So you are going to learn about ETL pipelines and all. So for that ETL pipelines, for building those kind of ETL pipelines, PySpark will help you. Okay. And data workflows, what are the workflows you are going to have in that pipeline means what? After this task you have to do this task, after this task you have to do another task. So that is the pipeline. So it helps you to build these pipelines. You can automate the things. So first you process this data, then you go for this data, process that, do that. You can design the pipelines. Okay. And you can also use PySpark to train the machine learning models. Okay, and process the real-time streaming data. Do you know what is streaming? So you use this Amazon Prime, Netflix and all. Those are what? Streaming platforms. So all the time there will be something streaming on that. So continuously to the millions of users. So those are the streaming platform. There also you require this PySpark because such a big data, such a huge number of users accessing that data, streaming, everybody is watching. So it has to handle that very properly, right? So for that we can use this PySpark because this is a distributed processing, right? So millions of users, in millions of users laptop, it has to stream. Okay, so it has to have that capability. So why PySpark? So again same story, handles big data very fast, used in distributed computing, fault tolerant. Okay, this is important thing here. Fault tolerant. What do you mean by fault tolerant? If any of your node fails, okay, suppose you have a cluster, okay, there you have some 10 systems. 10 systems you are doing the distributed processing. If any one of the node fails, imagine what happens. Because I have broken up the single task into 10 tasks. For each system I have assigned one task. So every system is running the task. One thing fails, one system fails. Then what happens? There is no connectivity. So everything will be lost because that is also a part of the task. If that is fail, then I cannot do the data analysis properly. So to avoid that, so it is having this automatic recovery. So whenever any node fails, that data what it is processing, that data we can recover automatically and we can assign to another system or you can replace that system with the another one. So data is not lost. You don't need to worry about, oh, what happens if this node fails? What happens if this system fails? My data will be lost. No. So if anything happens, you have that automatic recovery, recover your data and give that task to some other system. Okay. So it is very easy to use. It supports all these languages, Scala, Java, R and SQL. So you can pick your preferred language. You will have SQL queries also later in the upcoming sessions. Whatever you have learnt in SQL, you are going to apply that also here. Okay. So features, fast processing, easy to use, unified engine and fault tolerant and scalable. So these are the features of Apache Spark. So it can handle batch processing, streaming, machine learning, SQL, everything in one framework. Okay, and fault tolerant, obviously we know it can tolerate this failure, everything automatically recovered, lost data. So these are the features of Apache Spark, and it is very easy to use. You can have fast processing here. So it is much faster than Hadoop MapReduce, all these things. When it comes to difference between pandas and Pyspark. So pandas can handle what? Data set size from small to medium. Pyspark can handle very large or big data. Okay. When it comes to speed, pandas is very slow. Pyspark is much faster. When it comes to memory, pandas is having in memory on one machine. Pyspark is distributed across many machines. Okay. When it comes to use case, pandas is used in data analysis. Pyspark is used in big data processing. Not only data analysis, you can have big data processing in Pyspark. So Pyspark architecture, what exactly is there in the Pyspark? So you have this driver program, you have a cluster manager, you have executors. Executors means what? Systems. Just now I told you, no? Number of systems. So those are called as executors. We can call it as nodes, worker nodes, executors, okay, or systems. And these worker nodes, what they do? They run the tasks. Okay, when I break down the big task into smaller tasks, these smaller tasks are run by what? Executors. Okay, and they do the computations and they store the result or data in the memory. So whatever the job we give, they will do. Okay. Then we have a cluster manager. Just like any organization is having one manager, here also we are having a cluster manager. What does cluster manager do? It allocates the resources to jobs. So if I want any node to run the job, I have to provide the sufficient resources, right? That resources is provided by the cluster manager. So if any node needs anything, it has to ask the manager. Manager will provide the resources. Okay. And so when it comes to cluster manager, we have different types of cluster manager. We have standalone, yarn, mesos, Kubernetes. So any one kind of cluster manager we can choose. Okay. Then we have driver program. This is the main thing. This is the main thing. Just like your main function in the program, your program starts executing from the main function, right? In the same way, here also the app, the code will run from the main app, that is the driver program. Okay, so it creates the Spark session, converts the code into task and send them to executors. So driver program, what it will do? It will create the convert the code into tasks. So first let us say I give one big code. Okay, driver program, what it will do? It converts that code into tasks and send those tasks to the executors. Executors will run those tasks and management is done by cluster manager. Okay, this is what you have to understand. Okay, so here we have Spark ecosystem components. Which are the other components you have along with the Spark engine? So first we have Spark core main engine. So this main engine handles the task scheduling, memory management, RDD operations. Okay. Then comes Spark SQL. So here you can use SQL also. SQL queries, you can have data frames, Everything you can have here also. Same thing. So you have already worked with the data frames. So here also you can have data frames. Here also you can have SQL queries. Okay. And then coming to Spark streaming. So it processes the real-time data streams. Okay. And it also have, you can also have mlib and graphx. ML algorithms, and you have graph processing. You have certain graph, you can process that. So you can have different machine learning algorithms, everything. These are some of the ecosystem components you can have in the Spark, apart from the main components. Okay. How do you set up the Spark environment? Let us say we don't have Databricks now. So forget Databricks. Now we are setting it up manually. First you should know how to set it up manually. Okay. Then if you move for the Databricks, then you will feel that ease. Okay. See, this much I was doing earlier. Now you see I need not do anything. So that change you can feel it. So first if you do it in the local setup, then you can move to the Databricks. Okay. So what you have to do, first thing, install the Pyspark. So how do you install the Pyspark? Pip install Pyspark. So this is the command. Okay. This install what? It will install Pyspark, that is Python API. It will install Spark binaries, required dependencies, everything it will install, which are required for the Pyspark. Then you have to import that, and if you want you can check the Pyspark version. So you can print Pyspark dot double underscore version double underscore. If you use this, you can see what version of Pyspark you have installed. Okay. So this is the first step. Then before this first step, there is one important step. What is that? Installing Java. Install Java, then install Pyspark. Then create the Spark session. These are the three things. So from pyspark.sql, import the Spark session. Spark is equal to, as I explained you, Spark session is the class. Inside this class, we have this builder and then app name. So builder will help you to prepare to create the session, and app name gives one name to your app. Okay. And then get or create creates a new session, or returns the existing one if it is already created. Okay. So this is the main line you have to understand, you have to have in order to create the Spark session. So this is fixed. This line is fixed. You need to remember. So this is the code I have to write in order to create the Spark session. And what is the libraries you are importing? Spark session from Pyspark SQL. Okay. So this is the full code for creating the Spark session. I have put this in the try block, because if anything happens, okay, if any problems happens, I can catch it in the except block, okay, and I can handle it properly. So that's why I have written it in the try block. So you have to create the Spark session. If that returns true, the Spark session started successfully. It will print this message. If something happens, if it did not start properly, then it will print failed to start the Spark session. Okay. So your program does not stop if anything happens. Okay. If anything happens, you will get a message failed to start the Spark session. If everything goes well, you will get Spark session started successfully. Any one message you are going to get, either successful or failed. Okay. So that's why I have put it in the try block. So the same code, if you run it in the Jupyter notebook, see, uh, this is the code. So when I run it, I get this Spark session started successfully. Now it is successfully started. So once you start the Spark session successfully, what you can do, go to this URL I have told you, localhost 4040. There you can view the Spark UI. See, what are the jobs, what are the stages you can have. uh, let me start it once again. It will take some wait to start. Okay. So there is some port issues, I think. So if you run this, you will get the Spark session started successfully. First step, do this. Start your Spark session successfully. If it is started successfully, then you will be able to view this page. Okay, so there you can have the information about your jobs, everything. Okay, let me have one new notebook. Okay, let us try this tomorrow. It is taking long. Okay, so now have you understood up to this the basics about the Spark and Pyspark, everything? Any doubts or queries?